Okay, let us start then. Recording has been started. Yesterday we started with the numerical based on electric potential. Okay, where we do have these formulae. Do you remember that until and unless you know the formula, you cannot do anything with the numerical. फार्मूला अगर पता नहीं है तो you cannot solve the numerical, and it's really not feasible कि भाई मैं फार्मूला तो याद नहीं रखूंगा, इससे अच्छा तो मैं डिराइव कर लूंगा वहां पे फार्मूला, and I will have that one and we will solve the numerical. Definitely not the correct approach. Okay, फार्मूला याद रखना है मतलब you have two approaches over there. डायरेक्टली मगअप कर लो या फिर understand the formula, then automatically it will help you to memorize it. Okay, memorization will be there. कैसे भी करो, अंडरस्टैंड करके मेमोराइजेशन करो या फिर डायरेक्ट मगअप करो, कोई दिक्कत नहीं. बट एज लॉन्ग एज यू डोंट नो द फॉर्मूला यू कैन नॉट सॉल्व द न्यूमेरिकल. अगर फॉर्मूला पता भी है, चलो ओके, ये आर ए या फिर आर बी क्या चीज है ये भी तो पता होनी चाहिए. देयरफॉर अंडरस्टैंडिंग इज वेरी इंपॉर्टेंट. ओके, तो आर ए कैसे कैलकुलेट, क्या है एग्जैक्टली, वी नो दैट. ओके, आर ए इज गोइंग टू बी सम सॉर्ट ऑफ डिस्टेंस. Okay, RB is once again going to be some sort of distance. It is directly visible from the diagram itself. Okay, लेकिन जैसे न्यूमेरिकल में सिस्टम दिया होगा, सिनेरियो दिया होगा, अकॉर्डिंग टू दैट वी हैव टू पुट आवर अंडरस्टैंडिंग. अभी यहाँ पे दिखाया है कि भाई एक पॉइंट चार्ज है एंड वी हैव डिस्टेंस ऑफ पॉइंट ए एट आर ए एंड पॉइंट बी इज एट आर बी. पॉइंट चार्ज की जगह पे अगर लाइन चार्ज दिया होगा, ओके, लाइन चार्ज दिया हुआ है and you have 2 points, let us say point P and let us say point Q, then how you are going to find the distance of point A and point B from the source? This is nothing but your source. Here we have considered it is a line charge. So looking at this diagram, okay, distance in between the source and point A is RA. Distance between the source and point, over here we will call it as RP. Distance between the source and point Q will be RQ. Okay, but how we are going to find this distance? We need the coordinates of P and Q as well as the coordinate of intersection at these points. Okay, इतना ध्यान रखिए कि भाई लाइन चार्ज जब भी दिया होगा तो along with its उस लाइन चार्ज का कुछ डिस्क्रिप्शन भी दिया है. From that description and the points P and Q, you can definitely write down the coordinates for this point and coordinates for this point. Okay. ये चीजें we already done when we were solving the numerical for Coulomb's law, then electric field intensity due to line charges. ये चीजें we already did. Okay. तो यही चीजें फिर से अप्लाई करनी है टू गेट द डिस्टेंस. डिस्टेंस मिलने के बाद सिर्फ क्या है, फॉर्मूला चेंज है बिकॉज वी आर फाइंडिंग सम डिफरेंट क्वांटिटी. बट हाउ टू गेट द डिस्टेंस वी हैव ऑलरेडी done that. In yesterday's session we have solved a numerical. Okay, and probably you have gone through that numerical at home. ये पूरा डिस्कशन किया था. Then let us go with next numerical. Okay, talking about the electric potential due to certain amount of charge. Write down the numerical statement. We have a line charge of 45 nanocoulomb per meter. Okay, we are given with rho L is uniformly distributed along z axis. जब भी ये बात आती है along z axis, अभी मुझे बताइए, if we have coordinate system and this is our z axis, what will be the x and y coordinates of any point on z axis? Those will be 0. So here it is given that x and y coordinates of this line charge, okay, this line charge are 0. We have to define the z coordinate and z coordinate will depend on the coordinates of P and Q. Now we are given with another 2 point charges Q1 and Q2. of same quantity, same amount, 75 nanocoulomb, which are located at Q1 at 300 and Q2 at 030. Find the potential difference VPQ if P is at some point and Q is at some another point. तो अगर आपने यहाँ पे ध्यान दिया होगा तो we do have three different charges system. So first we will find VPQ due to line charge, then we will find VPQ due to Qn, and then we will find VPQ due to Q2. So voltage or potential difference independently due to line charge and Q1 and Q2, and at the end we will add them all. Okay, this is the procedure. This is what we understand from the given system in the numerical. So steps: calculate potential difference due to rho L, Q1 and Q2. Add all voltages together and we will get the final amount of potential difference in between the 2 points P and Q. Let us write down the given quantities. We are given with rho L is equal to 45 nanocoulomb per meter, which is placed on the Z axis. Then Q1 and Q2 of 75 nanocoulomb, okay, at 300 and 030 coordinates. We need to find, to get the final answer, we need to find VPQ. Okay, if P is at something and Q is at something. Okay, what formula we will require? The potential difference due to line charge. यहाँ पे अगर आप देखते हो तो मैंने नोटेशंस अभी चेंज कर दिए हैं. यहाँ पे मैंने लिखा है आर क्यू अपॉन आर पी, आर क्यू अपॉन आर पी. ये अगर उल्टा पुल्टा हो गया तो you will be in trouble. You will be in trouble for sure. Why? Because if you go into the formula, we will go back. Formula. जा भाई back. Oh, ज़्यादा ही back चला गया. My goodness. One moment, please. Where go to? Let me do once again. Sorry for the inconvenience. Okay. If you think about over here, VAB. देखो यहाँ पे VAB is something similar to एंड पॉइंट एंड स्टार्ट पॉइंट. मैं नोटेशन की बात कर रहा हूं, ध्यान से देखिए. V एंड पॉइंट एंड स्टार्ट पॉइंट इज इक्वल टू Q अपॉन 4 पाई एप्सिलॉन 0 1 अपॉन R एंड पॉइंट minus 1 upon R start point. Okay, distances of the start point and end points. Similarly, if we talk about a line charge, we end and start. Rho L is equal to 2 pi epsilon 0 ln of, okay, R. यहाँ पे क्या आएगा? Start. यहाँ पे क्या आएगा? End. If we say that in the numerical, the notation is given like this: PQ, VPQ. Find the potential difference VPQ. So rho L upon 2 pi epsilon 0 ln. So our start points becomes Q and our end points become P. तो नोटेशन के ऊपर जरा ध्यान दीजिएगा. अगर नोटेशंस उल्टे पुल्टे लिख देते हो, even if you know the formula, you do the calculations correctly, your answer will get wrong. Okay, ये important था यहाँ पे. So we will go on solving the numerical now. Why? Because we wanted to discuss this one. Then VPQ is equal to Q into 4 pi epsilon 0 RP 1 upon RP minus 1 upon RQ. Okay. And the start points. Now solution. First we will deal with the line charge. VPQ is equal to rho L upon 2 pi epsilon 0 Ln RQ upon RP. Okay. In case of line charge, distance is calculated by drawing perpendicular line on the line charge. Okay. यहाँ पे थोड़ा सा समझ लीजिए, आपके पास लाइन है. ओके. इस लाइन पे एक पॉइंट अज्यूम किया. इस पॉइंट के लिए x and y coordinates are 0 because that line charge is on the z axis. We have point q. Let us assume, okay, p के coordinates क्या दिए हुए हैं? 3 4 0. So what we will do, we will draw a perpendicular. अब भी मुझे अगर इस पॉइंट से लेके पॉइंट P तक का डिस्टेंस कैलकुलेट करना है, we will require the third coordinate. बरोबर? And this third coordinate will be same as that of another point. तो ये भी 0 आ जाएगा. Okay? If we talk about the perpendicular distance between the line charge and the point Q, which is situated at 543. For this point, okay, for this point, we know that x and y coordinates are 0. The third remaining coordinate will be as that of the point Q. ये 3 आ जाएगा. Okay, and now we do have the two coordinates and simply we can find the distances. Okay, this is very important. This diagram for the first time it is important. Later on it's okay if you do not draw the diagram, it's fine. Okay, जैसे इस numerical में मैंने ये diagram नहीं draw की थी because I wanted to explain the diagram to you. So RQ is the, yes.
सर सर एक डायग्रामचं परत सांगा ना प्लीज.
Okay, okay, fine. पूरी diagram मिटाता हूँ. And let us redraw the diagram. क्या हो गया? Let us say this is our line charge. Okay, this is a line for line charge, and this line is on z-axis. Therefore, any point on this line will have x and y coordinates as 0. We need to identify the third coordinate. Why? Here we have point P, whose coordinates are 340. We want to find the distance in between the source and the observation point, that is P. ये distance find करना है. To find the distance we need to have the both coordinates. P के तो coordinates है. We have to find the coordinates for this point. तो इस point के लिए x and y coordinates will be 0 and third coordinate is same as that of another point. Another point कौन सा है? P. इसका z coordinate क्या है? 0. Therefore we will write down the third coordinate as 0 for this point. Let us take another example. Q है. Q is at 543. Okay, and we want to find the distance in between the source and the point Q. Distance find करने के लिए we will require the coordinates of this point also. This point is on the line charge, and we know that for this line charge x and y coordinates are 0. What will be the third coordinate? It will be same as that of other point. ये 3 है, इसलिए ये भी 3 है. Okay, this is what I explained to you, and if you want to have much more explanation, I will strongly suggest to refer 9th standard geometry textbook. Okay, fine. So itna explanation is sufficient and necessary. I was joking to refer the 9th standard geometry book, but to how to get the third point, this is how we get the third point. Okay, so now I will remove this diagram once again because we do have lots of mathematics written over here. Sorry. and RP is the length of perpendicular drawn from the point P to the source. Okay, we are saying that RQ is distance and RP is distance in between the source and the observation point. So how to get them? So we can find the distance RQ. This is destination and this is source. Okay, so RQ can be found by this formula and RP can be found by this formula. Okay, what are these formulae? Uh, to the best of my knowledge, we have done this calculation, I guess 30 or 35 times. Okay, so here onwards, here onwards, I will expect you to solve these calculations. Okay, ये calculations आप लोगों ने करने हैं here onwards. So we can find VPQ because we do have RQ ka value, we do have RP ka value. So put all the values in the formula. 45 nano upon 2 pi epsilon 0 की value आपको पता है. I take this value as 10 raised to minus 9 upon 36 pi because I don't use 991 ms calculator. If you are using 991 ms calculator, epsilon 0 is your constant 32. You can use that one directly from the calculator. Put the values and we will have 200.07 volt for potential difference generated due to the line charge. What procedure we followed? Have the formula, find the distances, put the values in the formula, get the answer. Straightforward. Same things we are going to do for Q1 and Q2. So due to Q1, here point P is at 340, point Q is at 543, and Q1 is at 300. So same diagrams. Let me draw it somewhere. Sorry. So we do have point charge Q1, sorry, Q1, and we have a point P and we have a point Q. So this is at a distance RP and this is at a distance RQ. P के कोऑर्डिनेट्स है, Q के कोऑर्डिनेट्स है और Q1 के भी कोऑर्डिनेट्स है. Find the distances RP and RQ. Okay, so we will have the calculation of RP, the coordinates of destination minus coordinates of source, and put the values into the formula of VPQ. Q is given as 75 nanocoulomb upon 4 pi epsilon 0, 1 upon 4 minus 1 upon root 29. Okay, and we will have the VPQ generated due to a point charge Q1 as 43.34. Even if Q2 is of same value, its coordinate is different, its position is different. Therefore, the potential difference generated due to Q2 will be different. Okay. Now, due to Q2, we can find we are given with Q2 coordinate, P coordinate, and Q coordinate. Therefore, we can find RP and RQ. Okay. Put the values into the formula and get the answer. That's it. Okay. So we have one value, equation number 1. We do have second value, equation number 2. We have third value, equation number 3. And the final potential addition of the all three values. Okay. So we have the potential difference VPQ due to rho L and Q1 and Q2 equal to 342.63 volt. Okay. If you now look at the solution, it's bulky, it's lengthy. But if you think what exactly you are doing, first find coordinates. Second, find distance. Third, put values in formula. बस इतना ही कर रहे हो आप लोग, ज्यादा कुछ नहीं कर रहे हो. सिर्फ दिखने में बहुत लेंदी दिख रहा है इसलिए डर लगता है. ओके. फाइंडिंग द कोऑर्डिनेट्स जो डायग्राम मैंने बताई आपको आसान है. फाइंड द डिस्टेंस, आप 30 times, at least 30 times we did that. And if still if you are struggling with this under root. Okay, these under roots, you can see these under roots over here. ये अंडर रूट्स के साथ अगर आप स्ट्रगल कर रहे हो तो you need to study a lot, probably 10 hours per day only electromagnetics. Okay, and at the end भाई जो भी वैल्यूज मिले हैं इक्वेशन नंबर 1, इक्वेशन नंबर 2, इक्वेशन नंबर 3 उनको ऐड कर दो because we want to have the total potential difference due to all charges. Okay, this is a numerical where we actually call it as a superposition numerical. Okay, now let us go for the next numerical. यहाँ पे ना थोड़ा सा ट्विस्ट है, सिमिलर न्यूमेरिकल है. लेट अस एनालाइज द न्यूमेरिकल फर्स्ट. टू यूनिफॉर्म लाइन चार्जेस. ओके, रो L1 दिया है और रो L2 दिया है. ओके, of 8 nanocoulomb per meter. Each are located at x is equal to 1 and z equal to 2. अच्छा, rho L1 is at x is equal to 1 and z equal to 2. Y coordinate नहीं पता. And rho L2 is located at x is equal to -1, y is equal to 2, z उसका पता नहीं है. With free space. ये important है यहाँ पे. मतलब इप्सिलॉन 0 कंसीडर करना है. अगर अगर यहाँ पे नहीं दिया होता फ्री स्पेस, then also we would have considered epsilon 0 only. But अगर यहाँ पे मेंशन किया होता within the medium with relative permittivity of 2, then we are talking about epsilon r. तो ये ऐड करना पड़ता था. फिलहाल नहीं है तो इसका डिस्कशन बाद में करेंगे. ओके, इफ पोटेंशियल एट ओरिजिन इज 100 वोल्ट, ये इंपॉर्टेंट लाइन है, इसकी वजह से न्यूमेरिकल रॉन्ग हो जाता है. आपको क्या दिया हुआ है, पोटेंशियल पे 100 वोल्ट ऑलरेडी है. क्यों है पता नहीं है, लेकिन है. ओके, so given that at origin we have a potential of 100 volt, then find the potential at point 413. मतलब क्या करना है, we need to find the potential due to line charge, due to line charges. तो अपने पास V1 आएगा, अपने पास V2 आएगा, इन दोनों की एडिशन करेंगे तो we will get the final potential difference. But along with this straightforward procedure, we have to take care of this distance, group D numerical. What is this? This is a group D numerical. In electromagnetics, it happens that some of the times to make the numerical difficult, they may provide you redundant data, जो necessary नहीं है. But sometimes some data has to be considered very, very carefully. This is a group D numerical. Okay. Steps. Oh, sorry, one moment. Sorry. So let us go into the steps, what we exactly procedure we are going to follow. First, find V due to rho L1, find V due to rho L2, add about 2. This is the procedure. Okay, but something special about the 100 volt at the origin. So let us see what is the given data. So rho L1 of 8 nanocoulomb per meter at x is equal to 1 and z equal to 2. Rho L2 of 8 nanocoulomb per meter at x is equal to -1, y is equal to 2. क्या find करना है, potential at 413, point P expressed as 413. Formally, what we have, due to line charge, voltage is expressed as rho L upon 2 pi epsilon 0 Lm Rp upon Ra. Ra is something was the final point, end point, and Rb something related to the starting point. Solution. Due to line charge rho L1, so this is the geometry. Okay, जो मैंने previous diagram draw की थी ना, वही diagram है. So we are given with rho L1. We want to find the distance in between the point P and point O origin with respect to line charge. तो ये पॉइंट P है, ये पॉइंट ओरिजिन है, और इनका डिस्टेंस लाइन चार्ज से कहाँ पे है वो फाइंड करना है. फॉर दिस लाइन, द ब्लू लाइन, x is equal to 1 and z equal to 2 and y was unknown. So what is the y coordinate? This one is 1 because P has y is equal to 1. यहाँ पे ये 0 लिखा है y coordinate because origin has y coordinate is equal to 0. अगर अगर 1 की जगह पे, इस 1 की जगह पे 5 होता तो इस 1 की जगह पे 5 लिखते थे. y coordinate will be same as that of P. Okay. So this is the diagram we discussed in previous numerical, and here I put it in a ready-made way. So we can find the RP. So 4 minus 1 bracket square, 1 minus 1 bracket square, 3 minus 2 bracket square. Similarly RO, so 0 minus 1, 0 minus 0, 0 minus 2, everyone bracket square. So we do have RP and RO, okay. And, sorry, and we will now put the values into the numerical, into the formula. Here a careful attention must be expressed. VPO लिखा है, ओके VPO लिखा है. आपको क्या दिया है? पोटेंशियल एट ओरिजिन, पहले से ही वहां पे पोटेंशियल है, तो ओरिजिन से P की तरफ मूव किया है. ओके, वी हैव मूव्ड फ्रॉम ओरिजिन टू P and we have expressed the formula, put the values and get the answer. Straightforward. This is VPO value. Okay, VPO value. But at origin, we know that we have already 100 volts. So we have to take care of that. Therefore, actual voltage is equal to ये जो भी वैल्यू आई है -49.90 -100 जो ऑलरेडी वहां पे प्रेजेंट है. So this is the actual voltage at point P due to rho L1 because the origin is already at 100 volt. Same procedure we are going to follow for line charge rho L2. rho L2 के लिए क्या है? Okay, ये है rho L2. rho L2 के लिए we have given that x is equal to -1 and y is equal to 2. Okay, x is equal to -1 and y is equal to 2. The third coordinate is यहाँ पे 3. Why? This is 3. Z coordinate of P is 3. The Z coordinate over here is 0. Why? Because Z coordinate over here is 0. And what are RP and RO? Those are the perpendicular distances in between the source and the observation point. तो फिर से वही करो, RP find करो, RO find करो and put the values in the formula. Get the final answer. Okay, therefore, due to line charge rho L2, we have RP, we have RO, we have the formula. Put the values into the formula and get the answer. Since but since our origin ये VPO जो लिखा है ना, ये जो वो O है, this O is already at 100 volt. Therefore, actual voltage is -118.70 minus 100 is equal to -21870. So this is potential due to rho L1 and this is potential due to rho L2. So therefore total potential at P is equal to addition of the two. That is, I missed negative sign over here, -368.6 volt. Okay, फिर से यहाँ पे क्या किया? वही चीज है. Find the distance, put the values in the formula, get the answer. इतना ही है. So work done, potential are just getting the right values. That's it. Okay. It is very, very, very straightforward. Now, these were the numerical concentrating on the work done and electric potential. Probably you have noted down these numerical into your notebook. Okay. In next session, In next session we are going to start with the potential gradient. Okay, ये फॉर्मूला डिराइव किया था बराबर. इलेक्ट्रिक फील्ड इंटेंसिटी इज negative of gradient of voltage. Okay, or these are the gradient expressions in Cartesian, cylindrical and spherical coordinate system. ये expression तो याद रखने ही पड़ेंगे. Okay. So we will deal with the potential gradient and its associated numerical in next session. But right now I have a plan for the session, and that plan is, let me stop sharing. Let me stop the sharing the screen. One moment. Also, I want to download the attendance right now. Fine. Now, what we are going to do, we are going to check your notebook right away, right this moment of time. I have downloaded the attendance, and what you are going to do, you are going to turn on your camera. No need to show yourself, but show your notebook. Okay. I will take the names of the students. That particular student will turn on the camera. Others, please wait for your two students logged out, one student logged out. Okay, now 13. Okay, great. Anyone else want to leave the classroom? तो 17 स्टूडेंट्स थे, अटेंडेंस थे. उसमें से 4 लोगों ने तुरंत लीव कर लिया, मतलब उन्होंने लिखा नहीं है. Do we have anyone else? No. Okay, fine. I will take the names. Just show me your notebook. Also, along with this, I will give you privacy. I will stop the recording. Okay. I am stopping the recording now.